Hello. Today would like to talk about the MRI. Probably I'm gonna make several videos about this topic. So of course we're gonna learn the concept of MRI as a machine, how it works, the physical principle behind it, and so more. The book that I'm reading from or taking the lessons from actually is called MRI from photo to photon. Okay, I'm gonna go chapter by chapter. Now this is chapter 1. Okay, the introduction about the science behind the MRI machine. Okay, so let's start. First of all, MRI stands for magnetic resonance imaging. Okay, so it's manipulating nuclear properties to create detailed maps of tissues inside the body. So, first of all, what's the advantage or what make MRI special? First of all, it's excellent for soft tissue like the brain, especially if there's tumors, the heart, etc. It's unlike the CT scan or X-ray, which actually struggle with those type of tissues. Okay. Second, we have its non-ionization, which means it's safe for multiple use. So we could do a lot of images for the same patient, and we won't be worrying about the side effects of radiation, like in X-ray, for example. And something else, actually, we have multi-planar image. Okay. So we have a lot of slides together, okay? And we have also its specific image, tissue specific image. So if we would like to study a specific type of tissue inside the body, we could actually adjust the image, the weight of the image, as we're gonna see later, how we could actually find or learn about specific tissue inside the body. So let's delete this. Okay. Now, so MRI is used, as I mentioned, for brain, spine, joints, heart, liver, tumors. Okay. So any soft tissues, unlike bones, could be used for. So how, if I want to explain how does MRI work? First of all, you have to, the basic principle, let's change color. We have a lot of colors here. Let's say, for example, red. Okay, so still. Okay, so the principle here that the body contains a lot of hydrogen atoms, mostly in water and fat. Okay, so the basic idea here is about the secret. Actually, is about the hydrogen atoms. Okay, so those hydrogen actually nuclears. Protons, exactly, those protons inside the hydrogen atoms have a magnetic property. They behave like tiny spinning magnets. When you place those body that contains a lot of hydrogens, actually, when it's placed in a strong magnetic field, we refer it to B0. Okay, the field of the magnet in the device. They align with the field like compass. Okay? Like compass needles. Now we have also the concept of RF, which is the radio frequency pulses that knocks them out of alignment. So we have those, we have those hydrogens that act like, they act like tiny spinning magnets. Okay? So they have different directions without applying the magnet. Okay? Now what happens when I apply the external magnet, the strong magnet that is usually about 1 to 3 Tesla. So those hydrogen atoms actually, they will align with the external magnet. Okay? They will be in one direction. They will align with this magnet. Okay? Now, when I use an RF, which is radio frequency pulses that knocks them out of their alignment. So, this is my RF radio frequency. So this guy, for example, he will be aligned with the external field. Suddenly he will be knocked out of this alignment. So he will spin in different direction. Like that, okay? So, MRI machine detect those tiny signals and we build images from them. Because as they relax back into alignment, they emit signals. So those actually, when they got affected by the RF frequency, they will, of course, going back. They relax and back into the alignment. When they do that, means they go back to the initial state when they were actually affected by the external field. Okay? When they do that, when they relax and they go back to their initial state, they emit signals. Okay, this is the signals they emit when they go back to their alignment with the external field. Now, these signals, those signals actually, we take them and we analyze them to get the MRI image. I hope that was clear in sort of way. So this is of course we're going to explain this further more, but this is the general idea behind the MRI. Okay, so the basics or the basic parts of, sorry for my writing, it's not very good, but the idea is most important here. So what actually the parts? The basic parts, of course. We have a strong magnet, about 1.5 to 3 Tesla. Okay? We have also RF coils, actually more than one. We already just explained the function of it. It actually send and receive radio signals. Of course, we need the computer system to actually analyze the image and make the final map. We have the gradient coils as well. Now, the point, this is very important because actually it localizes where signals are coming from. Okay, so when we gather the signals again, we know that this signal is coming actually from this coordinate and this signal is coming from this coordinate. That of course is going to shape the image or the map. So those coils actually are very, very important. Okay, So why is the signal different in different tissue? Why is the signal different or differs in different tissues? This is the title of from the book. Let's explain what they meant actually. Why is the signal different in different? That was very bad writing. Okay. So they mean actually why the signals, if we have, this is the image in general, this is what they meant actually. We have, this is the brain, for example, okay? This is the brain. Why actually some parts would look different from each other, simply. So this will be like more gray, this would be more dark, this would be more light, etc. Okay, that of course gives a diagnostic informations. So there's two reasons. Actually, there's three reasons behind this. First of all, we have each tissue returns the signal slightly differently due to different things, which means the tissues actually returns the signal slightly differently from each other. And that is because of T1, T2, and the proton density. Now you would say, what is that? Okay. Now we're gonna say, what is that? Proton density. Well, T1 actually, T1, how fast protons at T1 actually is a time. Okay, stands for time. T1 relaxation. How fast protons realign with the magnet field. Okay? While as T2 relaxation, how fast protons lose their coherence with the magnetic field. This is the two differences. And thirdly, proton density, how many protons are in the tissue. Those are three factors actually what makes the different tissues look different from each other in the MRI image, okay? For example, fat, okay? Fat has short T1 and short T2. For this reason, if in T1 weighted image, they will show as bright tissue. Now, why I would say T1 weighted image? Because the image in MRI is either T1 weighted or T2 weighted, means where it depends on T1 or T2. You could consider it like that. Whereas, for example, water has long T1 and long T2. For this reason, they would show bright on T2 images. Okay, here bright. Here bright, but the difference here is we're talking about T2, T1, and here's T2. So eventually what we could say before we finish this video, actually MRI is based on nuclear magnetic resonance. Actually also detects the behavior of protons in water and fats. Also, the contrast is biological in MRI system, not physical like X-ray. And I hope in other video, of course, we're gonna talk about chapter 2, go further. This chapter was actual introduction, and as I mentioned before, the name of this book that I'm learning from or making the tutorial from is actually MRI from photo to photon. Thank you so much.